Hello everyone. Welcome to today's Masterclass on AI Ethics and Governance, offered by JUBATUS Institute of Management and Technology, JIMTech. It is an absolute privilege to introduce our instructor, a visionary leader whose work bridges human psychology, technical innovation, and corporate strategy, Dr. Chris M. Jayachandran. Dr. Chris brings a unique, multidisciplinary approach to AI, holding advanced degrees in both computer science and psychology. His pioneering PhD research specifically focused on the intersection of developmental psychology and AI/ML models. Rather than just studying technologies, Dr. Chris actively builds them, having engineered novel frameworks like advanced Kahonen self-organizing maps for cognitive applications. Cutting-edge findings by Dr. Chris on ADHD and personality disorder diagnostics with AI in limited clinical diagnostic infrastructure settings are widely recognized and published across prestigious platforms, including IEEE, Springer, Elsevier indexed book chapter, and in UGC Careless journals, along with an article on cultural leadership in Harvard Business Review. He is India's first neurobranding consultant and creator of the REAP framework, which expands into reflect, effect, and perfect. Beyond his corporate innovations, Dr. Chris is deeply committed to regional academic growth. He has a distinguished record of serving the premier educational institutions across Tamil Nadu as a trusted resource person within the developmental psychology and digital technology landscape. In the commercial sphere, he has experience in working for an award-winning AI product development company incorporated in Michigan in the capacity of AI business analyst and project manager. During this tenure, he also consulted for a Fortune 500 company, working with transnational team members from Chicago, Poland, Israel, Pune, and Bengaluru. Alongside founding JUBATUS, a private limited company entity focusing on EdTech, digital transformation, AI/ML solutions incorporated with the Ministry of Corporate Affairs, Government of India, his prolific work has earned him multiple district, regional, and national level accolades, including the prestigious UGC Government of India Research Project grant. Pertaining to this masterclass on AI ethics and governance, Dr. Chris holds an official course audit certification from the National Institute of Standards and Technology, NIST, of the United States of America, for completing their risk management framework for systems and organizations. Version 2.0, the gold standard methodology for organizational security and privacy risk management. His dual mastery of global technical guardrails and human behavior makes him uniquely qualified to guide us through the ethical boundaries of tomorrow's AI technology landscape. Please join me in welcoming Dr. Chris M. Jayachandran.
Artificial intelligence is no longer a future technology. It's already shaping how we work, hire employees, approve loans, diagnose diseases, monitor security, and even create content. I hope all of you would agree with me on this. But with this unprecedented power comes an equally unprecedented responsibility. What happens when an AI system discriminates against qualified candidates? Who is accountable when an autonomous system makes harmful decisions? How do we ensure transparency in technologies that even their creators struggle to explain? And perhaps most importantly, how do we innovate responsibly without slowing progress? Welcome to this masterclass on AI ethics and governance. I am Dr. Chris M. Jayachandran. My doctoral research has focused on AI/ML. I completed my PhD from the University of Madras under the guidance and supervision of Dr. K. Shyamala, Head and Associate Professor, Postgrad and Research Department of Computer Science, Dr. Ambedkar Government Arts College Autonomous, Chennai, 39. Madam has been instrumental in my knowledge acquisition around AI/ML domain. I take this occasion to thank Madam. Well, over the next hour, we will explore the ethical foundations of artificial intelligence, examine real-world failures, understand emerging global regulations, learn practical governance frameworks, and discover how organizations can build trustworthy AI systems. Whether you are a student, educator, executive, policymaker, technology leader, researcher, or even an AI practitioner, this session will equip you with practical tools to navigate one of the most important challenges of the digital age. Let's begin. Why AI ethics matters. Every transformative technology in history has brought extraordinary benefits. Electricity, for example, transformed industries. The internet, on the other hand, transformed communication, is it not? Artificial intelligence, however, is transforming decision making itself. The difference is that AI increasingly influences choices that affect people's lives. When algorithms decide who gets hired, who receives credit, who is selected for medical treatment, or who becomes a target of surveillance, ethical considerations become more than academic discussions. They become societal necessities. According to global research organizations and policy bodies, trust has become the single most important factor influencing successful AI adoption. Organizations that ignore ethics may achieve short-term gains. Organizations that embed ethics into their AI strategy build long-term trust, resilience, and sustainable innovation. This masterclass is ultimately about one central idea: trustworthy AI. The four pillars of ethical AI. To understand AI ethics, we must first understand four foundational concepts. They are bias, fairness, transparency, and accountability. Together, these principles form the foundation of responsible AI. What is bias? Let's start with bias. Many people assume that machines are objective. After all, machines do not have emotions, preferences, or prejudices. But AI systems learn from data, and data reflects human history. If the presented historical data contains inequalities, discrimination, or imbalances, the AI systems can inherit and amplify those patterns. Imagine training a hiring algorithm using 10 years of hiring decisions from an organization where most successful candidates were male. The AI may learn that male characteristics correlate with success and unintentionally disadvantage female candidates applying for the same job. The machine is not intentionally discriminating, it is simply reproducing patterns it observed in historical data. This phenomenon is known as algorithmic bias, and it remains one of the most significant ethical challenges in AI today. What is fairness? Fairness is often described as the antidote to bias. However, fairness in AI is more complex than treating everyone identically. Different groups may experience technology differently. A facial recognition system that performs accurately for one demographic group but poorly for another cannot be considered fair. A recruitment system that consistently disadvantages older candidates is not fair, even if it follows identical rules for everyone. Fairness, therefore, requires continuous monitoring, testing, and mitigation. It is not a one-time achievement, rather, It is an ongoing commitment. Now consider transparency. Imagine being denied a mortgage loan. You ask why, and the answer is simply, the algorithm decided. Would that be acceptable? Most people would say no. Transparency means understanding how AI systems reach conclusions. Stakeholders should understand the purpose of the system, the data it uses, its limitations, and the reasoning behind important decisions. Transparency becomes especially critical in high-impact sectors such as healthcare, finance, education, and public services. Without transparency, trust becomes impossible. Finally, accountability. Perhaps the most important question in AI governance is this: who is responsible when AI causes harm? Is it the developer, the vendor, the organization using the system? Or can we even blame the AI itself? The answer is straightforward. AI cannot be accountable, period. People and organizations must be accountable. Effective governance frameworks ensure that responsibility is clearly assigned and that mechanisms exist for oversight, remediation, and continuous improvement. Accountability is what transforms ethical principles into organizational practice. When AI goes wrong, AI ethics becomes easier to understand when we examine real-world failures. These cases, friends, demonstrate that ethical challenges are not hypothetical. They are already happening. Amazon recruitment system. One of the most frequently cited examples comes from Amazon. The company experimented with an AI-powered recruitment system designed to identify promising job applicants. The system was trained using historical hiring data. Unfortunately, the historical data reflected years of male-dominated recruitment patterns. As a result, the algorithm learned to favor characteristics associated with male applicants. In some cases, resumes containing references to women's organizations or activities were penalized. Engineers attempted to correct the issue, yet the bias persisted because it was embedded deeply within the training patterns. Eventually, the project at Amazon was abandoned. The lesson or the takeaway is very clear. AI does not eliminate bias on its own. Without proper safeguards, it can automate bias at scale right in the production environments. Clear view AI. Another controversial example is Clear View AI. The company collected billions of publicly available photographs from websites and social media platforms. These images were used to build powerful facial recognition capabilities. The technology demonstrated impressive technical performance, but it raised profound ethical questions. Did individuals consent to their biometric information being collected? Should publicly available data be treated as freely exploitable commercial assets? Can surveillance technologies be deployed without clear safeguards? The resulting legal challenges and regulatory actions highlighted the growing tension or friction between technological capability and privacy rights. DeepMind and the NHS. A third case involved a collaboration between DeepMind and the United Kingdom's National Health Service. The goal was admirable: develop AI systems capable of detecting acute kidney injuries. However, approximately 1.6 million patient records were shared without adequate transparency and consent mechanisms. The controversy was not about malicious intent, it was about trust. Patients expected healthcare data to be protected and used responsibly. The incident demonstrated that even beneficial innovations can fail when governance mechanisms are insufficient. A new generation of risks. Generative AI introduces a completely new category of ethical challenges. Unlike traditional AI systems that either classify or predict, generative models of AI create. They generate text, images, audio, video, software code, and increasingly, generative AI systems also make decisions on behalf of all of us. This creative capability renders extraordinary opportunities, but at the same time, it also creates extraordinary risks. Intellectual property challenges. One of the most debated issues involves intellectual property. Many generative AI models have been trained using vast collections of online content. Books, articles, images, music, software code. Creators around the world are asking a simple question: should AI systems be allowed to learn from copyrighted works without explicit permission? Courts and regulators are still working through these questions. The outcomes will shape the future of AI innovation. Deep fakes. Deepfakes represent another major concern. Artificial intelligence can now create realistic videos and audio recordings of people saying or doing things that never occurred. Political leaders can be impersonated. Corporate executives can be mimicked. Ordinary individuals can become victims of identity manipulation. The challenge extends beyond misinformation. It threatens the very concept of evidence on authenticity in the digital world. Hallucinations and synthetic data. Generative AI systems can also hallucinate. In other words, they can confidently present false information as factual. The danger is not merely incorrect answers. The danger, rather, is in convincing incorrect answers with which people will be carried away. At the same time, synthetic data offers opportunities for privacy preservation, but may inadvertently produce biases embedded in original datasets. These challenges remind us that technological sophistication does not automatically guarantee reliability. Reflection question. As we conclude this first module, consider the following question. If your organization deployed an AI system tomorrow that affected thousands of people, would you be able to answer these three questions? How was it trained? How does it make decisions? And who is accountable when it fails? If the answer to any of these questions is unclear, governance must become a priority. Module 2: Global Regulatory Frameworks. Friends, imagine this scenario. Your organization develops an AI solution in India, but this AI solution is deployed in Europe. The cloud infrastructure for this AI solution is operating from the United States, and some of the training data originates from Asia Pacific markets. Now, consider a simple question. Which laws apply? The answer is increasingly complex. As AI adoption accelerates worldwide, governments, regulatory bodies are racing to establish rules that protect citizens while encouraging innovation. For organizations, this creates both a challenge and an opportunity. The challenge is navigating a rapidly evolving regulatory landscape. The opportunity is building governance systems that are resilient, trusted, and future-ready. In this module, we will explore the world's most influential AI regulations, understand how different regions approach AI governance, and examine practical strategies for achieving compliance in an increasingly regulated environment. Friends, has any of you pondered over as to why governments are regulating AI? Historically, regulation often followed innovation. Cars appeared before traffic laws. The internet expanded before cybersecurity frameworks. In a similar fashion, social media transformed society before governments fully understood its impact. Artificial intelligence is following a similar trajectory. For years, AI development moved faster than regulation. Organizations focused on innovation, efficiency, and competitive advantage. But as AI systems began influencing employment, healthcare, finance, education, law enforcement, and public services, policymakers recognized the need for safeguards. The goal of regulation is not to stop innovation. The goal is to ensure that innovation occurs responsibly. Just as aviation requires safety standards and pharmaceuticals require clinical testing, AI increasingly requires governance mechanisms that reduce harm while preserving benefits. This balance between innovation and protection lies at the heart of modern AI regulation. The cost of regulatory failure. Regulations rarely emerge in a vacuum. Most are responses to real-world failures. Data breaches exposing millions of users. Facial recognition systems producing discriminatory outcomes. AI-generated misinformation influencing public discourse. Opaque algorithms denying opportunities without explanation. These incidents revealed a common pattern. Technology was advancing faster than accountability. As a result, governments around the world began asking critical questions. How can organizations demonstrate fairness? How should AI systems be audited? Who is accountable when automated decisions cause harm? And how can citizens maintain control over their personal information? The answers are now taking shape through a growing network of regulations, standards, and governance frameworks. The EU AI Act. When historians look back at the evolution of AI governance, one regulation will likely stand out as a turning point: the European Union AI Act. Often described as the world's first comprehensive AI law, the EU AI Act has become the benchmark against which many future regulations are being measured. Why is it so significant? Because it shifts the conversation from voluntary ethics to legally enforceable obligations. Organizations can no longer simply claim they are responsible. They must demonstrate it. Understanding the risk-based approach. At the core of the EU AI Act is a simple but powerful principle. Not all AI systems pose the same level of risk. A grammar checking application does not present the same dangers as an AI system used to determine prison sentencing or medical diagnosis. Therefore, regulation should be proportional to risk. The EU AI Act organizes AI systems into four categories: minimal risk, limited risk, high risk, and unacceptable risk. Let's explore each category. Unacceptable risk. At the highest level are systems classified as unacceptable risk. These are applications considered fundamentally incompatible with European values and fundamental rights. Examples include certain forms of social scoring that evaluate citizens based on behavior, manipulative AI systems designed to exploit vulnerabilities, and some forms of real-time biometric surveillance in public spaces. These systems are outrightly prohibited, not regulated, not monitored, simply prohibited. This represents one of the strongest regulatory signals that some AI applications cross ethical boundaries society is unwilling to accept. High-risk AI systems. Next are high-risk AI systems. These are not banned, but they face significant compliance obligations. Examples include AI used in recruitment and hiring, educational assessments, critical infrastructure management, healthcare diagnostics, credit evaluation, and certain law enforcement applications. The reasoning is straightforward. Errors in these systems can significantly affect people's lives. Therefore, organizations deploying high-risk AI must demonstrate robust governance, transparency, risk management, documentation, and human oversight. In essence, the higher the risk, the higher the responsibility. Limited and minimal risk. Limited risk systems occupy the middle ground. Examples include chatbots, virtual assistants, and AI-generated content. I'm quite sure that almost all of us would have used AI systems belonging to this particular category. The primary requirement here is transparency. Users must know when they are interacting with AI. Similarly, AI-generated content should be disclosed appropriately. At the lowest level are minimal risk systems, spam filters, recommendation engines, video game AI. These applications generally face minimal regulatory obligations. The focus remains on enabling innovation while concentrating regulatory resources where harm is more likely. Compliance requirements. For organizations, compliance extends far beyond legal paperwork. The EU AI Act requires a range of operational controls. Organizations must maintain technical documentation, implement quality management systems, monitor performance continuously, maintain records of AI model development and deployment, conduct risk assessments, and establish meaningful human oversight mechanisms. In other words, compliance is becoming an organizational capability rather than a legal exercise. Successful organizations will treat governance as a part of product design rather than an afterthought. Global approaches to AI governance. One technology, many regulatory models. While the European Union has chosen a comprehensive legislative approach, other regions have adopted different strategies. This diversity creates what many experts call a fragmented regulatory landscape. Understanding these differences is essential for organizations operating globally. The United States of America's approach. In the United States, AI governance has traditionally emphasized innovation and sector-specific oversight. Rather than creating one comprehensive AI law, regulators often focus on existing agencies and frameworks. Healthcare AI may fall under healthcare regulators. Financial AI may fall under financial regulators. Consumer protection issues may be addressed through existing enforcement mechanisms. The United States has also emphasized risk management frameworks such as the NIST AI Risk Management Framework. Rather than prescribing detailed rules, these frameworks provide organizations with practical guidance for identifying, assessing, and managing AI risks. The philosophy is flexibility. Allow innovation to flourish while establishing guardrails for responsible deployment. The United Kingdom approach. The United Kingdom has pursued what many describe as a principles-based approach. Instead of introducing a single AI law, existing regulators are encouraged to apply current laws and principles to AI systems. These principles include safety, transparency, fairness, accountability, and contestability. The UK model seeks to avoid excessive regulation while maintaining flexibility in rapidly evolving technological environments. Supporters argue that this approach encourages innovation, but critics worry it may create inconsistency across sectors. Either way, it represents a distinct governance philosophy. China's approach. China has taken more centralized and proactive regulatory approach. Particular attention is given to generative AI, algorithmic recommendation systems, and content governance. Organizations deploying public-facing AI services often face registration requirements, security reviews, and content-related obligations. The focus extends beyond technical risk to include societal stability, information integrity, and national strategic priorities. Understanding these differences is essential because multinational organizations frequently operate across multiple regulatory environments simultaneously. For example, a multinational company having its headquarters in New York can very well have its subsidiary office in Beijing. Areas of global convergence. Despite differences in legal frameworks, an interesting trend is emerging. Many countries are converging around common principles. Whether we examine Europe, North America, Asia Pacific, or international organizations, several themes appear repeatedly, such as human oversight, transparency, fairness, accountability, privacy, safety, and robustness. The specific legal mechanisms may differ, but the underlying objectives are remarkably consistent. This convergence provides organizations with an important strategic insight. If you build AI systems according to strong governance principles today, you are more likely to satisfy future regulations tomorrow. Compliance as a strategic advantage. Many organizations view compliance as a burden, a cost, a barrier to innovation. However, leading organizations increasingly see governance differently. They view governance as a competitive advantage. Why? Because trust has become a strategic asset. Customers prefer trustworthy organizations. Employees prefer responsible employers. Investors increasingly evaluate governance practices, and regulators reward proactive compliance. Organizations that establish strong governance capabilities early will likely adapt more easily to future regulatory changes. Building an AI inventory. One of the most practical starting points is creating an AI inventory. Think of it as a central register of every AI system used within the organization. Why systems are deployed, who owns them, what data do they use, what decisions do they influence, what risks do they create. Many organizations are surprised to discover how many AI applications already exist across different departments. Without visibility, governance becomes impossible. An inventory creates the foundation for accountability. Slide 33. Risk mapping. The next step after creating the AI inventory is risk classification. Not every AI system deserves identical scrutiny. Organizations should classify systems based on potential impact. A chatbot answering internal FAQs requires different controls than an AI system screening job applicants. By mapping systems according to risk, organizations can allocate resources more effectively and focus governance efforts where they matter most. Data governance alignment. Strong AI governance begins with strong data governance. Organizations should understand where data originates from, how it is collected, who can access it, how long it is retained, and whether its use complies with legal and ethical expectations. Friends, we must always remember this principle. The quality of AI governance can never exceed the quality of data governance. If the data foundation is weak, ethical AI becomes impossible. Human oversight. Perhaps the most important compliance strategy is maintaining meaningful human oversight, particularly for high-risk decisions. Humans should not simply rubber stamp algorithmic recommendations. They should understand the context, review uncertain cases, challenge the questionable outputs given by any AI system, and retain authority to intervene when necessary. This concept, often called human in the loop governance, represents a recurring theme across global regulatory frameworks. Module 2 wrap-up. The key takeaways of Module 2. Friends, as we conclude this Module 2, we need to remember three important lessons. First, AI regulation is no longer a future possibility. It is a present reality. Second, while regulations differ across jurisdictions, they increasingly converge around common principles such as fairness, transparency, accountability, and human oversight. The third lesson: compliance should not be viewed as a defensive exercise. It is a strategic capability that enables trustworthy innovation. The organizations that thrive in the AI era will not be those that simply build the most powerful systems. They will be the organizations that build the most trusted AI systems. In the next module, we move from regulation to execution. We will explore how organizations can operationalize AI governance through ethics boards, risk assessments, procurement controls, and practical governance structures that transform principles into everyday practice. Operationalizing AI governance. By this time in the masterclass, friends, we have explored two critical dimensions of responsible AI. First, we examined the ethical foundations of artificial intelligence. We learned fairness, transparency, accountability, and trust in this regard. Second, we explored the evolving regulatory landscape and discovered how governments around the world are transforming ethical expectations into legal requirements. But a critical question remains: how do organizations move from theory to practice? How do we transform principles into processes? How do we turn compliance requirements into operational capabilities? And how do we ensure that AI governance becomes part of everyday decision making rather than a document sitting on a shelf? This is where many organizations struggle. They understand the risks, they understand the regulations as well, yet they lack the structures, processes, and accountability mechanisms needed to govern AI effectively. In this module, we will explore how organizations can operationalize AI governance through governance frameworks, risk assessments, procurement controls, and practical decision-making structures that make responsible AI a reality. Why governance fails? The governance gap. Let's begin with a simple observation. Most AI failures are not caused by technology alone. They are caused by governance failures. A biased hiring algorithm is rarely the result of malicious code. A privacy breach is rarely caused by a single technical mistake. An unreliable AI system rarely fails because engineers lacked intelligence. Instead, these failures often emerge because organizations lacked oversight. Responsibilities were unclear, risks were not assessed, warning signs were ignored, or accountability was absent. In other words, governance failed before technology failed. This distinction is important because it means that many AI risks can be prevented long before deployment. From reactive to proactive governance. Traditionally, organizations have approached governance reactively. A problem occurs, an investigation follows, policies are updated, and eventually lessons are learned. This approach may work for isolated incidents, but it is insufficient for AI. Why so? Because AI systems continuously evolve. They learn, they adapt, they interact with changing environments, and they often influence decisions at scale. Modern governance, therefore, requires a proactive approach. Instead of asking, "What went wrong?" organizations must ask, "What could go wrong?" and more importantly, what safeguards should be in place before it happens. This shift from reactive oversight to governance by design is one of the most important transitions organizations must make. Building an AI ethics board. The need for structured oversight. Imagine approving a major financial investment without any review committee. Imagine launching a new pharmaceutical product without regulatory oversight. Most organizations would consider that unacceptable. Yet, many organizations deploy AI systems without any formal governance structure. This creates significant risks. AI systems affect technology, law, ethics, privacy, operations, and business strategy simultaneously. No single department possesses all the expertise required to evaluate these dimensions effectively. This is why many organizations are establishing AI ethics board. What is an AI ethics board? An AI ethics board is a multidisciplinary governance body tasked with overseeing the responsible development and deployment of artificial intelligence. Think of it as an organization's ethical navigation system. Its role is not to slow innovation, but its role is to ensure innovation remains aligned with organizational values, stakeholder expectations, and regulatory requirements. The board serves as a bridge between technical teams, business leaders, legal advisors, compliance specialists, and external stakeholders. Who should be on the AI ethics board? One of the most common mistakes organizations make is treating AI governance as solely an IT responsibility. In reality, productive AI governance requires diverse perspectives. A robust AI ethics board may include representatives from technology and engineering, data science, legal and compliance, cybersecurity, human resources, risk management, business operations, and in some cases, external ethics advisors or independent experts. Why is diversity important? because AI risks are multi-dimensional. A technically accurate system can still create legal liability. A legally compliant system can still generate reputational damage. A profitable system can still violate societal expectations. Diverse perspectives help organizations to identify risks that may otherwise remain invisible. Key responsibilities of the AI Ethics Board. A fully functional AI Ethics Board typically performs four critical functions. First, strategic oversight. The board evaluates whether the proposed AI initiatives align with the organizational goals and ethical principles. Second, risk review. The board examines high-risk use cases before development and deployment. Third, policy governance. It establishes standards, procedures, and accountability mechanisms. And the fourth, continuous monitoring. Governance does not end when a system goes live. The board reviews performance, incidents, audits, and emerging risk throughout the AI lifecycle. In essence, the AI Ethics Board provides ongoing stewardship rather than one-time approval. Decision governance. Before deployment, ask better questions. Let's imagine your organization is planning to deploy an AI-powered recruitment platform. Before implementation, several critical questions should be asked. Could the system disadvantage certain demographic groups? Can applicants challenge decisions? What happens if the model produces inaccurate recommendations? Who reviews edge cases? What safeguards exist? These questions form the foundation of an algorithmic impact assessment, often referred to as an AIA. What is an AIA? Algorithmic Impact Assessment. An algorithmic impact assessment is a structured process used to evaluate the potential consequences of an AI system before deployment. You can think of it as the AI equivalent of an environmental impact assessment. Before constructing a major infrastructure project, organizations assess environmental risks. Similarly, before deploying AI, organizations should assess ethical, social, operational, and legal risks. The goal is not to eliminate all risks. The goal is to understand the risks completely so as to manage those risks responsibly. The four core questions. When conducting an algorithmic impact assessment, four fundamental questions should guide the process. First, who will be affected? Second, what could go wrong? Third, how severe would the consequences be? And fourth, what safeguards exist to prevent or mitigate harm? These questions encourage organizations to move beyond technical performance metrics and consider broader societal implications. Assessing bias and fairness. One of the most important components of an AI is fairness evaluation. Organizations must examine whether the system performs consistently across different groups. Does accuracy vary by gender, age, ethnicity, language, geography. If disparities exist, organizations must determine whether they are justified, acceptable, or indicative of harmful bias. This process requires both technical analysis and ethical judgment. Metrics alone cannot determine fairness. Accountability and auditability. Another key objective of an impact assessment is establishing accountability. Every significant AI system should have a clearly identified owner, someone responsible for oversight, someone accountable for outcomes, someone authorized to intervene when necessary. Additionally, organizations should maintain audit trails. These records document decisions, model versions, risk assessments, approvals, and remediation actions. Auditability transforms governance from aspiration into evidence. AI risk tiering. Not all AI systems are equal. One of the biggest mistakes organizations make is treating all AI systems the same. Friends, consider two examples: a grammar checking tool internally used by employees, and an AI system that determines eligibility for medical treatment. Both use artificial intelligence capability, yet their potential consequences differ dramatically. This is why risk tiering is essential. The 4 risk tiers. Organizations can classify AI systems into 4 broad categories: minimal risk, moderate risk, high risk, and critical risk. Minimal risk systems generally support productivity and create limited potential harm. Moderate risk systems influence operational decisions but maintain manageable consequences. High risk systems can significantly affect individuals, finances, or organizational reputation. Critical risk systems, on the other hand, involve life-changing decisions, public safety, healthcare, or even fundamental rights. The higher the risk, the stronger the governance requirements. Matching controls to risk. A critical risk system should not receive the same level of scrutiny as a grammar checker. Instead, governance controls should scale with risk. Minimal risk systems may require only registration and standard monitoring. Moderate risk systems may require documented assessments and periodic reviews. High-risk systems should undergo formal impact assessments, fairness testing, and human oversight. Critical risk systems may require independent audits, continuous monitoring, executive review, and emergency shutdown mechanisms. Risk-based governance ensures resources are focused where they create the greatest value. The hidden governance challenge. Many organizations assume AI governance only applies to systems they build internally. In reality, most organizations increasingly rely on third-party AI vendors. It could be chatbots, recruitment platforms, analytics tools, productivity assistants, generative AI solutions. These tools often arrive as ready-made products. But governance responsibilities do not disappear simply because someone else built the technology. Buying blind. Imagine purchasing a vehicle without knowing its safety rating, or implementing cybersecurity software without understanding its vulnerabilities. Yet, organizations frequently acquire AI systems with limited visibility into how they were trained, tested, or governed. This practice is often called buying blind. Friends, it creates substantial risk. When organizations deploy third-party AI, they often inherit the vendor's weaknesses, biases, and compliance challenges. Questions every organization should ask. Before adopting an AI solution, organizations should ask several critical questions. Some of the examples could possibly be the following. Where did the training data originate? How is customer data protected? Has the model been tested for bias? What security controls are in place? Can outputs be explained? Does this vendor support human oversight? What certifications or audits have been completed by this vendor? And perhaps more importantly, can the vendor provide evidence rather than promises? Friends, we should always remember that responsible procurement begins with transparency. Trust, but verify. A useful principle in AI procurement is very simple. That would be trust, but verify. Marketing claims are not governance evidence. Organizations should request documentation regarding AI model repository, audit reports, compliance certifications, risk assessments, security attestations, and governance policies from the vendor. Verification creates confidence, and confidence in turn builds trust. Trust reduces risk to a great extent. Governance as a business enabler. Moving beyond compliance. At this stage, some organizations still view governance as a barrier. A series of approvals, additional paperwork, more meetings, more complexity. But leading organizations see governance differently. They recognize that governance accelerates responsible innovation. Why? Because governance creates clarity. Teams understand expectations. Risks are identified early. Decisions become more consistent. Stakeholders gain confidence, and innovation occurs within trusted boundaries. Governance is not about saying no. It's about knowing when to say yes responsibly. Key takeaways of Module 3. Friends, as we conclude this Module 3, remember 3 key insights. First, Effective AI governance requires structure, ethics boards, accountability mechanisms, and clear ownership transform principles into action. Second, risk assessment must occur before deployment, not after failure. Algorithmic impact assessments help organizations identify and manage risks proactively. And third, governance extends beyond internally developed systems. Third-party vendors, procurement processes, and external partnerships must always be subject to oversight. Ultimately, governance is not a destination, it is an organizational capability, one that enables innovation while protecting people, organizations, and society. In our next module, we will explore the technical and human safeguards that make responsible AI possible. We will examine bias mitigation, explainable AI, and human in the loop frameworks that help transform governance principles into practical operational controls. Technical and human mitigation. So far in this masterclass, we have explored the ethical foundations of AI, examined the global regulatory landscape, and learned how organizations can operationalize governance through structures, policies, and risk assessments. But governance alone is not enough. Policies cannot eliminate bias. Committees cannot explain black box decisions. Frameworks cannot independently prevent harmful outcomes. Ultimately, responsible AI requires action. It requires practical mechanisms that reduce risk, improve transparency, and ensure that human judgment remains central to all important decisions. This is exactly where technical and human mitigation strategies become essential. In this module, we will explore three critical pillars. First, how organizations can identify and reduce bias in data and AI models. Second, how explainable AI helps us understand complex machine decisions. And third, how human-in-the-loop systems create meaningful oversight in increasingly automated environments. Together, these strategies transform AI governance from policy into practice. Why bias persists? Let's begin with an uncomfortable truth. Most organizations do not intentionally create biased AI systems. Yet, biased outcomes continue to emerge. Why? Because bias is rarely introduced at a single point. Instead, it can enter the AI system at multiple stages: during data collection, during labeling, during feature selection, during model training, and even during deployment. Think of bias as water contamination in a pipeline. If contamination enters at any stage of the pipeline, it can affect everything downstream. This is why bias mitigation requires a life cycle approach rather than a one-time intervention. The data problem. AI systems learn from examples presented to it. The quality of those examples determines the quality of the AI system itself. Imagine training a facial recognition model using millions of images, but most of those images represent only a limited demographic group. The AI model may perform exceptionally well for some populations and poorly for others. The issue is not the algorithm itself. The issue is representational imbalance. In simple terms, the AI system has not seen enough diversity to learn fairly. This highlights a fundamental principle of ethical AI. If the data is biased, the outcomes of the AI system are likely to be biased. Hidden biases in historical data. Historical data presents another challenge. Organizations often assume historical records represent objective truth. But historical records frequently reflect past inequalities. Consider recruitment data from industries where certain groups have traditionally been underrepresented. In terms of finance industry, lending data influenced by decades of economic disparities, or even healthcare data shaped by unequal access to medical services. When an AI system learns from any such data source, without careful intervention, it may reproduce historical inequalities rather than correct them. The result is what many experts call automated discrimination. Identifying bias. The first step in mitigation is measurement. After all, organizations cannot fix what they cannot see. This requires systematic bias audits. Data scientists examine whether different groups experience different outcomes. Are error rates consistent across populations? Do recommendations vary unfairly? Are certain groups systematically disadvantaged? These are some of the important questions organizations should mull over in order for identifying biases. By measuring these patterns, organizations can very well move from assumptions to evidence. Building better data sets. One of the most effective mitigation strategies is improving the quality and diversity of training data. This process is often called dataset diversification. The objective is simple: ensure that all relevant groups are adequately represented. But diversity alone is not enough. Organizations must also document how such data was collected, labeled, processed, and eventually validated. This metadata creates transparency and enables future audits. Think of it as maintaining a chain of custody for data. Fairness aware AI. Modern AI systems increasingly incorporate fairness aware design principles. Instead of optimizing only for accuracy, organizations can introduce fairness constraints during model training. These techniques help prevent the model from amplifying existing inequalities. The goal is not perfection. No AI model is perfect. The goal, rather, is to create outcomes that are more equitable, more transparent, and more aligned with organizational values. Responsible AI requires balancing performance with fairness. Continuous monitoring. A common misconception is that bias testing happens once before deployment. In reality, bias can emerge over time. Data changes, user behavior evolves, markets for products and services fluctuate, societies transform. As a result, AI models that performed fairly yesterday may behave differently tomorrow. This phenomenon is known as model drift. Organizations must therefore establish continuous monitoring that track fairness, accuracy, and performance throughout the lifecycle of the AI system. Friends, responsible AI is not a one-time project. Rather, it is a continuous process. The black box problem. Now, let's address another major challenge: understanding how AI makes decisions. Many advanced machine learning models are incredibly powerful, but they are also incredibly complex. Even experienced developers may struggle to explain why a particular prediction was made by a machine learning algorithm. This creates what is commonly known as the black box problem. The system generates outputs, but the reasoning process remains hidden. Why explainability matters. Imagine being denied a loan, being rejected for a job, or denied access to a healthcare service. Naturally, you would want an explanation, is it not? Why was this decision made? What factors influenced the outcome for the rejection that I am being affected with? Could the decision be challenged by me or someone associated with me? These are the practical questions that any commoner can raise. Without explainability, organizations cannot answer these questions effectively and convincingly. Without explanations, trust begins to erode. Explainability, therefore, serves both practical and ethical purposes. It improves accountability. It supports compliance and strengthens stakeholder confidence. From black box to glass box. The goal of explainable AI, often called XAI, is pretty straightforward. Transform black boxes into glass boxes, not necessarily revealing every mathematical detail, but providing enough insight for humans to understand, evaluate, and challenge decisions. Explainability helps bridge the gap between machine intelligence and human understanding. It creates transparency where opacity once existed. Slide 69. Understanding LIME, Local Interpretable Model Agnostic Explanations. One popular explainability technique is known as LIME. Despite the intimidating name, the idea behind local interpretable model agnostic explanations is straightforward. LIME focuses on a single decision. It examines which factors most influenced a specific prediction. Imagine asking, why was this applicant rejected? LIME identifies the variables that contributed most significantly to that particular outcome. This creates a localized explanation that humans can understand. Shape feature importance. Another widely used approach is SHAPE, shapely additive explanations. SHAPE helps organizations understand how different features contribute to model behavior. It can explain both individual decisions and broader patterns across the entire model. Think of SHAPE as revealing which variables have the greatest influence on outcomes. Example for variables can be any one of the following: age, income, education, experience, or any other relevant factor. These insights help organizations identify hidden risks, validate assumptions, and improve transparency. Explainability builds trust. Ultimately, explainability is not just a technical capability. It is a trust-building capability. Stakeholders are more likely to trust systems they can understand. Regulators are more likely to approve systems they can audit. Employees are more likely to adopt systems they can interpret. And customers are more likely to accept decisions when meaningful explanations are available. Transparency strengthens legitimacy. Can AI replace human judgment? As AI systems become increasingly sophisticated, an important question emerges. Can AI replace human judgment? The answer in most high-stakes situations is no, it cannot. AI excels at identifying patterns, processing large volumes of information, and generating recommendations. But humans bring qualities that machines still struggle to replicate. Such qualities can be context, empathy, ethical reasoning, common sense, and accountability. This is why human in the loop frameworks have become a cornerstone of responsible AI. What is human in the loop? Human in the loop, often abbreviated as HITL, refers to systems where humans actively participate in most important stages of AI decision making. Rather than fully automating decisions, organizations establish checkpoints where human expertise can validate, modify, or override AI recommendations. The objective is not to compete with AI. Rather, the objective is collaboration, combining machine efficiency with human judgment. Where human oversight matters most. Not every AI application requires the same level of oversight, but certain situations almost always justify human involvement. Examples for such situations would be healthcare decisions, employment screening, financial approvals, legal assessments, public safety applications, and any decision affecting fundamental rights. In these contexts, human review provides an essential safeguard against errors, bias, and unintended consequences. Slide 75. Avoiding automation bias. Simply placing a human in the process is not just enough. Humans can develop what psychologists call automation bias, a tendency to trust machine recommendations without sufficient scrutiny. Imagine a pilot blindly trusting automated navigation despite contradictory evidence, or a recruiter automatically accepting an algorithm's ranking of candidates. Effective human-in-the-loop systems must encourage critical thinking rather than passive approval. Humans should challenge AI, not merely endorse it. Human override authority. A hallmark of mature governance is clear override authority. Organizations must define who can intervene, when intervention is required, and how decisions are escalated. When an AI system exhibits uncertainty, unusual behavior, or potential harm, humans must have both the authority and the capability to act. This principle is especially important in critical risk environments where the consequences of failure can be severe. Learning through feedback. One of the most valuable aspects of human-in-the-loop systems is continuous learning. Every human correction creates an opportunity for improvement. When experts identify errors, the insights can be used to refine models, improve training data, and strengthen future performance. This creates a powerful feedback loop. Humans improve the AI, and AI supports human decision making. The relationship becomes collaborative rather than competitive. Technology alone is not enough. Friends, as we bring this module to a close, it is important to remember a fundamental truth. Responsible AI cannot be achieved through technology alone. The most advanced algorithms in the world cannot independently guarantee fairness. The most sophisticated models cannot automatically create trust, and the most comprehensive governance policies cannot eliminate every risk. Responsible AI emerges when technical excellence and human judgment work together. A human-centered ecosystem. The future of AI governance is not about choosing between humans and machines. It's about designing systems where each contributes its strengths. Machines provide speed, scale, and analytical power. Humans provide wisdom, context, ethics, and accountability. Organizations that successfully combine these capabilities will be best positioned to harness AI responsibly and sustainably. Key takeaways of this masterclass. Friends, as we conclude this module 4, remember these key lessons. Bias must be actively identified, measured, and mitigated throughout the AI life cycle. Explainability transforms opaque systems into understandable and accountable tools. Human-in-the-loop frameworks ensure that critical decisions remain subject to meaningful human oversight. And ultimately, responsible AI requires a partnership between technology and humanity. The goal is not simply smarter systems having no say by a human being. The goal rather is wiser systems where human-in-the-loop control and perpetual collaboration exists. With that, this is Dr. Chris M. Jayachandran thanking you for being a wonderful audience throughout this AI ethics and governance masterclass. If you would like to receive an online verifiable certificate with a unique certificate ID from JUBATUS Institute of Management and Technology, JIMTech, for the completion of this AI ethics and governance masterclass, please send an email to jimtech.certificates@gmail.com. The email ID is now being shown on the screen. Once we receive your email, we will reply with additional details and instructions.